Okay, so we're going to model a quarter of a cargo hold for your particular ship. I'm going to start off with a static structural analysis, similarly as in workshop number 1. And we're going to start working on the geometry in Design Modeler. So the first thing that I'm going to do is create a set of different sketches that would help us generate sort of the surfaces that we need to represent our different structural members, such as outer plating, frames, girders, and so on. So I'm going to start in the YZ plane and create a sketch. And first I'm going to set some grid settings here, which will help me to draw. And the first thing that I'm going to define is the profile for the outer plating. I'm going to do this by just drawing a simple L here. And then give that the appropriate dimensions. So my ship, in this case, the half width of the ship is 10 meters. And the total draft of the ship is 14 meters, like that. I'm also gonna put in a radius here of 1.25 meters between the bottom and the side, like that. So I can go back, and now I'm going to create a second sketch, again in the YZ plane. So sketch number 2. Look at that. And now I'm going to define the sort of planar profile of a single frame. So I'm going to do that by using a polyline. It's not that important where I place these points, it's just I'm going to put in some dimensions later. And that's a closed end curve. So now I'm going to put in some dimensions. I want that to be the same width, of course, as the outer plating, the same height. And then I want the floors here, the web of the floors to be 1.5 meters. And similarly in the side structure I want them to be 1.5 meters, like that. And I'm also going to put in a radius here, similar to the outer plating, like that. Okay, so now we have the two sketches. We have sketch number 1 highlighted in yellow here, which represents sort of the outer plating, and sketch number 2, which represents the frame here. Okay, so we're going to continue with sketching the key line and the keel or girder. So I'm going to start with going through to the XY plane, create a sketch. Look at that. I've already set show grid and snap here. I'm going to draw a simple line here from the origin out and set the appropriate dimensions. So in my case I want the section to be 10 meters long. Like that. What we can do now to it can be difficult to see how these sketches are oriented relative to each other. So if I look at this plane, I cannot see the key line sketch going here. So what we can do is to select the sketch that we want to look at, let's say the frame sketch, go down to details and set always show sketch. So if I go to another plane now, the Y plane for example, where I have the key line, I will still see this frame sketch, so we can see that their position relative to each other are as we want. And now I'm going to draw the, I'm going to go to the ZX plane, and I'm going to draw the planar profile of the keel or the girders. So I'm going to use a rectangle, starting at the origin and just drawing some random rectangle and then assigning it the correct dimensions. So of course I want it to be the same length as my section, 10 meters, and I want the height to be same as the floor, so 1.5 meters, like that. And now we can see that we have both the frame and the keel or girder correctly positioned relative to each other. Okay, so now I'm going to continue by extruding the outer plating. So we're going to hit create, extrude, and the geometry we're going to use is the first sketch. You see this highlighted in yellow here, so that's the profile we're going to extrude. Hit apply, direction vectors, that's normal to the plane, extend type fixed, and we want that of course to be 10 meters long. And then we hit generate. Okay, so that's our outer plating. Looks good. Now we're gonna do the frames. So we'll start by creating surfaces from sketches. Again, this is where the sketches come in handy. We can use our second sketch here, highlighted in yellow. Hit apply. Now we have to select operation. We have to select add frozen. So that means that we're generating a separate part. So we'll have the frame will be one part and the outer plating will be one part. And we can set the thickness here to whatever we want, like that, and then just hit generate. And there we see that we've generated a frame. And to do the other frames, we can use an operation called pattern, which make it fairly efficient. So geometry, we select the geometry that we want to make a pattern of, in this case the frame. Hit apply. And then we have to select the direction. And in this case we can use this line, key line that we defined earlier. And we see this arrow that indicates the direction of the pattern, which looks good. We can flip that if you want. First we set the offset, so in this case I want the spacing to be 4 meters between the frames, and I want to generate 2 additional frames. And then we hit generate. And we can see that we have now 1, 2, 3 frames. Okay, so now we'll continue by modeling the keel. Again, we're going to use surfaces from sketches, and we have to find that particular sketch. There we see it highlighted in yellow, looks good. We just hit apply. Again, model that as a separate part, so select add frozen, and we assign some thickness and hit generate. So that will be our keel. And now we can use the same sort of pattern operation as we did for the frames. So we select the keel geometry, hit apply, select our direction, we can use that edge. Again we see the arrow, it looks good. We hit apply. The offset here, in my case I want it to be 2.5 meters, and I want to generate 3 additional girders, and just hit generate. So now we can see we have our frame and girder system all set up. Okay, so now we're gonna start defining our stiffeners in the bottom and in the side. This step is optional. You could use sort of an equivalent area approach, as it's mentioned in the instructions, but it is fairly straightforward to define these stiffeners. So I'll show you how to do it, and you can decide for yourselves. We start by making a new sketch. I'm going to go to the XY plane, hit new sketch, and then I'm just going to draw a simple line here somewhere between the fore and the aft part of the section. And then I'm going to use dimensions, length, distance, and set the distance between the keel and the first stiffener. So in my case it's 0.265. Go back to the modeling. And now I'm going to create a line from this sketch. So I'm going to use concept, lines from sketches, select that line, hit apply, and hit generate. Now the difference between this line and the sketch is that this line that I just created can be assigned different properties. So if I want to model a stiffener, I can do that by using beam elements. And I can assign those elements to this line that I just created. And ANSYS has a fairly efficient way of doing this. So we can start by creating our cross-section of our stiffener. In my case, I'm going to use a simple L section. Here we see that we have a predefined L section, and we can just go in here and edit these parameters as we wish. And we can see that the cross-section appears here in the model tree. If you have different stiffeners in the side and the bottom, you can of course define several different cross-sections. Okay, so let's go back to the model. And now we can select this line. If you go into the model tree, down here you have parts and bodies. You can expand that, select the line, you will see it highlighted. And here, cross-section, drop down that, and we can find L2 in this case. And now we have assigned a cross-section to that line, so we can have a look at that. We can zoom in a little bit. Here we can see the cross-section. If you can't see this cross-section, hit View and display cross-section solids. But as we can see, it's not oriented properly. It looks a little bit strange, so we have to fix that. So we can start by selecting this line body again. Offset type, we can set user defined. And now by changing the X and Y offsets, we can sort of define, you see that just moved. But right now we leave that at 0, 0. And the first thing we'll do is to rotate this section. So we select this line here in the viewport. And then you get in details here, we can set a rotation of 180 degrees. That looks good. And now we can go back to the line body and set a Y offset of like that. And now we can see that the section is oriented properly with, in relation to the outer plating. So we zoom out, and now we can use the same sort of pattern operation to generate several stiffeners in the hull bottom. So we're going to create pattern, geometry. We already selected that line there. Apply, direction, like that. The offset here will be 0.625, and I'm going to start with creating 2 more stiffeners. Hit generate. And we can see now that we've created stiffeners for the first section here. And then it's just a matter of repeating this pattern process. So start by selecting a geometry, like that, direction, same direction. And now I'm going to use 1.2 here to sort of, otherwise I will place a stiffener at on the girder. And I can make 4 copies of this, I think. Or even 5 copies, actually. Hit generate, like that. And we see that we're missing stiffeners here and here. So again, go back, use pattern, select that line, apply, direction, apply, and 0.625, and in this case 1 copy, and hit generate. And then you can sort of work with the other stiffeners in the same way. Okay, so now we're moving on to the stiffeners in the side, and we'll use very, very similar operations. And first we need to sketch a line on the side, and we can do that by creating a new plane. And here we select from face, so base face, and I'm going to select the side. Hit apply, and now we've created a new plane, plane number 4 here. We can hit generate. So now I'm going to select that plane and make a sketch in that plane. And now, very similar to the bottom stiffeners, first I'm going to set some show grid and snap, and then I'm just going to draw a single line from the fore to the aft part of the section. Place that line. I'm going to measure it from the end of the radius here, and I want that distance to be 1 meter, like that. And then I'm going to create lines from sketches, and I'm going to select the sketch that I just made, hit apply, and hit generate. Now we can go down into the model tree, select that line, and I'll use the same cross-section definition here as in the bottom. Let's zoom in and have a look at that. And again, we can see here that we need to work with these offsets to make this correct. So I'm going to use user-defined offset, and then like that. And now we have our first stiffener inside, and now again we use this pattern operations. Select the first stiffener, and then we select the direction. That will be a vertical direction, like this. And I want the distance to be 1 meter between these stiffeners, and I'll generate 12. Oh, that was 1 too many, 11. And there we have stiffeners along the entire side of the house structure. Okay, so now we have to create the inner plating for this section. So to do that, we'll go back to the YZ plane. I'm going to create a new sketch. Look at that. And here we'll simply sketch an L like that, and then we assign the appropriate dimensions. So, for example, the distance is 5 meters, and that will be 8.5 meters. and the height of this one will be 12.5 meters, like that. And we'll use that sketch to extrude the inner plating. So geometry, we'll select that sketch. The length, of course, is 10 meters, same as the length of the section. And we'll just hit generate. And there we can see the inner skin, inner plating of the section. What we can do now is go back to the model tree here and have a look at our surfaces. For example, we can start by clicking the first surface body here. We see that the outer plating is highlighted and that we have not assigned a thickness to this plating yet. So we're going to assign some thickness here to that. The other surface bodies here, we can see that we already assigned thicknesses to those as they were being generated. But again, the last surface here, the inner plating, 0 thickness, so we're going to assign a thickness to that as well. When we gotten this far, we could of course add stiffeners to the inner plating as well, or we could add stiffeners to sort of the girders or floors and so on. But basically it's the same operations that you repeat again. You can create planes on surfaces to sketch on the surfaces, and then just generate lines from sketches and repeat this procedure of assigning beam sections to those lines, and build up any level of detail that you want. Okay, so now that we've gotten this far, we've modeled all our structural parts, the stiffeners, the inner and outer plating, floors and girders and so on. We need to make sure that this model is fit for analysis. So the first thing we have to do is to make sure that all these different structural parts that we've defined are actually joined together. So we're going to hit Tools, Joint, and then we select the entire geometry and hit Apply, and then hit Generate. And now we can see that we've generated 201 joints between these different structural parts. What we also can do is to, in the model tree here, select all these different bodies, lines and surfaces, right click and form a new part. So now we can analyze this hull structure as a single joined part in ANSYS Mechanical. Okay, so here we have the model in ANSYS Static Structure, and it looks good, and we'll proceed in the same manner as we did with the stiffened plate analysis in the last workshop. So we start by going to the mesh. I'll just right click here and hit Generate Mesh with sort of the standard settings. Now we can have a look at that. That looks reasonable as sort of as a baseline, and we can work from that. We proceed here, and we'll start with assigning our boundary conditions. I'll just show an example here. I'm going to use fixed edges for these all these different edges on this side of the model. So I'll zoom in here and select some different edges. I'll select this, and as you can see, it could take quite some time to select all these different small edges. So what you can do is select a couple of edges and then use a function called extend to limits, Now you see that ANSYS automatically selects the rest of that edge, which makes life a little bit easier. And then I'll just hit apply. And then you have to, of course, define the other sort of symmetry boundary conditions, the boundary conditions between the side and deck intersections and so on, but you do that in a similar manner. So now we can move on to the loads. You could, of course, assign sort of static pressures on various parts of the inner and outer plating, exactly in the same way as we did for the simple plate analysis. But you could also add a linearly varying pressure or a hydrostatic pressure to the model. And I'll just show you how that is done. So we select that. We select the geometry that we want to apply this pressure to. We can do this simple procedure again. We select one surface here or one face and extend to limits. So now we'll apply this. I will apply this linearly varying pressure to the entire side structure. We enter the fluid density. We'll sort of define the acceleration, vertical acceleration, Z component. We can set the free surface location, and we want that at, let's say, 6 meters. Like that. And now we can see that we have the pressure increases with depth here, and we have the 0 point at 6 meters. So we can change that depending on the draft of your particular ship. We'll use 7 meters. Okay, so when we would assign sort of our boundary conditions and our loads, we can go to the solution and just do sort of look at the total deformation. We'll right click, hit solve. And there we have it. Now this is, of course, I haven't assigned all the boundary conditions and all the loads, but just to illustrate the process. What you also could do here is, if you go into the mesh, for example, you could try, similar to what we did in the plate workshop, you could try to, for example, change your analysis change your elements to quadratic elements by keeping the mid-side nodes, and run your solution again, and so on. You could also, of course, try to vary the mesh density, make sure that the results that you're interested in has converged. And of course, select the solution entities that you're interested in, if it's stress, strain, deformations, and so on. Okay, good luck with analyzing your own ships.